Okay, and we have an extrema down here. So what is it about 4? 4 shows up in both of those. Is it also an inflection point? Yes. It's also on this side is concave down and that side is concave up, but it's not, it does not signify an extrema, and that's what we would try to say up here on the first derivative, that it's an extrema. It's not an extrema. Not an extrema because the second derivative at 4 is also 0. It's a 0 of both of those, so we have to be careful about those. If they show up in both of those, take a real good look at them. They may or may not be extrema. They may or may not be inflection points. Is it an inflection point? Yes, it is also an inflection point. So it says discuss the concavity. I kind of ran out of space on mine right here. So our conclusion is, I'll just put it right here. Conclusion is f of x is concave up where? Give me an interval. Give me a better interval. Yeah, we're not stopping at 0. If I had this window better, it would continue to go up. Okay, so don't stop at 0. But it's concave up from negative infinity to 2. Is it concave up anyplace else? From 4 to infinity, yeah. And from 4 to infinity, concave down, where? From 2 to 4. And what are 2 and 4? They're the zeros of our second derivative. Okay? There we go. That is one problem. No, the others should go a little bit faster for us, but we have, we're developing the ideas here. Speaking of which, if I give you that problem, could you work your way through it? Find our extrema using the second derivative test. What's the first thing we need to do? Okay. Determine the first derivative. What's the second thing we need to do? Determine what? Okay, critical numbers of the function by setting what? First derivative equal to 0. Okay. What's the third thing we need to do? Find the second derivative. Okay. What's the fourth thing we need to do? Okay. Well, actually, it's critical numbers of the first derivative. Yeah, by setting the second derivative equal to 0. Okay. What's the fifth thing we have to do? Just because we got all these critical numbers doesn't tell us anything about extrema. The critical numbers of this step right here determine possible. I want you to put that word in there. Possible what? Extrema. Setting the second derivative equal to 0 helps us find possible what? Inflection points. What's going to throw a wrench into this? If what happens? Yeah, if something's a critical number of both, okay? Now, just because we have the critical numbers, I want to find extrema. These are possible extrema. So now I know I have some possible extremas because they don't show up as critical numbers in both of those. But I want to know, I don't want to know just if they're extremas. I want to know, are they maximums or minimums? Okay, so now we're going to determine maximum or minimum by doing what? Which one tells us concavity? Second one, okay, and if the concavity is concave up at that point, what point? Inflection point tells us change of concavity. If we know at this point that it's concave up because our second derivative is positive, concave up, it's positive. The function has a minimum, but we only know that because we put what into the second derivative? Critical number of the, well, yeah, of the function, we actually say. You can go back. Critical numbers is zeros of the first derivative. Unlike you, I keep wanting to say critical numbers of the first derivative. It's really not. It's critical numbers of the function by finding zeros of the first derivative. So these now are zeros of the second derivative, which are critical numbers of the first derivative. Okay, so we determine maximum minimum by, how can we say that, evaluating the sign of the second derivative at critical numbers of f of x. Let's put it in here. These are zeros of the first derivative. Just to make sure we're not confusing these. Okay? That's the work you need to do. Now, which piece of that do you not know how to do? Can you find a derivative? Sure. Check off 1, check off 3. Can you find zeros of a function? Yeah. Check off 2, check off 4. Can you insert values into a function and determine if it's positive or negative output? Yeah. Check off 5. Okay? But it's putting it all together. Now again, as I've said all semester, you have all the math you need for this course. You knew this math, all the math you needed from Algebra 2 and then, of course, trig thrown in there. But basically, everything we're talking about in here, you really found out in Algebra 1. But it's putting it together. It's packaging it. It's knowing when to use what. It's being responsible for remembering things like a product equal to 0 is what is the key in finding critical numbers. You need to make it a product equal to 0. So you can do the, one of the factors has to be 0-bit. So all of that is within your knowledge. Now, to find the derivative, you're going to have to know what the derivative of sine x is, cosine. The derivative of a double angle. Again, you may or may not know that. We're using this enough. You might have remembered it. What is it? 2 cosine squared x minus 1. But look in the front cover of your book. It has all of those in there. Okay. So I'm not going to talk to you anymore about that. You can do that problem. You're going to have some work to do, of course, to finish up things like that, but I don't think we need to take time to have me sit here and watch you take a derivative. Okay? Challenge for you. Here we go. This problem. We'll probably just finish up with this and then have the quiz. So take a moment, look at this. Okay, Shelley, what do you have there? Okay. Why don't you draw what you have? Let's see if we make sure we get a pen up here. Yep. And again, just look at the screen. Don't look down here. Just look to the screen. Okay, talk to us about it. It says f of 0 and f of 2 are 0. What does that tell us about the the graph?
I took it as I honestly wasn't sure.
Okay. Okay. Can someone help us out here? F of 2 and F of 0 and F of 2 equals 0 indicate what? Zeros. Okay. Do you want to? We'll just start over again. Lindsay, you want to show us what you have? You're left-handed?
No.
Right-handed? Okay. And don't look down there, just look at the screen. And okay, so label where F of 0 and F of 2 equals 0. So the inputs are 0, the inputs are 2, the outputs are 0. Okay? The second line. First derivative is positive if x is less than 1. Justify your graph.
The first derivative is positive.
Say that again.
If the first derivative is greater than 0, that means that it's increasing up until 1.
Okay.
Right?
Okay, so go ahead and make a mark there so we can see right there. Okay. It says, so we agree? Okay. The derivative at 1 is 0, which indicates what, Casey?
Oh, it indicates that it is a maximum. Like
Okay.
it's then you know that the slope of the tangent line is 0.
Okay. So if you draw a tangent line there, go ahead, Lindsay, you can give us a tangent line there. There you go. Okay. And that the slope of that tangent line is 0. Okay. The first derivative is less than 0 if x is greater than 1. What does that indicate to us?
On the right-hand side, it's decreasing when x is greater than 1.
Okay, because the derivative is 0 or is negative. Okay, and the second derivative is less than 0. What does that indicate to us, Kaylee? The very last line there. It's concave down. Doesn't say where, so it's concave down everywhere. Okay, thank you. Again, a problem like this is really, I like it because it makes you think, right? You can't just plug it in and get an answer. Okay, let's see. We got 5 minutes here. Average cost. Again, I'm not sure if it's 79 or whatever, but average cost. The manufacturer determined that the total cost of operating a factory is this. Okay, so the total cost is this. Now, I have a business calc class, and hopefully they're really up on all this business term, but maybe you have not talked about business terms in a while. Cost is comprised of fixed cost and variable cost, and obviously this fixed cost and variable cost is a little more than just a linear function. So someone took some data and looked over years or whatever time unit we have here and has determined that this function, not a linear one now, but this function, this quadratic, will best describe how much money the company has to pay to produce these items. Okay.